Hey, we're back. And in this little video, we're going to be dealing with this problem here. Which situation represents a proportional relationship between the hours worked, okay, so I can count hours, between the hours worked and the amount earned. Because remember, we always have to have at least two things to test proportionality for Matt and Jane. So here's Matt's earning in time, here's Jane's earning in time. And we're going to do this two ways. We're going to first do it by checking the ratios of each person, and we're going to also do it visually by graphing. So let's look at Matt's first here. So we know that if a relationship is proportional, we can test it using ratios. So I'm going to test by doing the dollars earned by the hours, the time. And I have to test each one of these. So 12 over 1. It's 12 over 1, that simplifies to 12. And then 20 over 2, that simplifies to 10. Those two are not equal, so this it's not proportional. I don't even have to check this third one because that and that are not equal, so they're not proportional. I'll do Jane in a different color here. Jane here, and again I'll do the dollars, hours, and if I do that, 12 over 1 simplifies to 1, and 24 over 2, that's 24 divided by 2, and 24 divided by, that's not 1, it's 12. I'm sorry, 12 divided by 1 is 12. 24 divided by 2 is also 12, and 36 divided by 3, 36 over 3, that ratio is also 12. Since these are all the same, since these are all the same, this is proportional. Remember, you can see that something's proportional, that no matter how the numbers in the relationship change, the ratio of the values doesn't change. So that's how we can tell. Okay, that's great. So I can see that Jane's is proportional and Matt's not. Well, what the heck does that look like visually? So let's graph. And I'm going to be moving this. So time is almost always on the x-axis. So I'm going to let this be x. I'm going to let this be y. And let's go ahead and label these things. Sorry, this thing's going in and out of focus. Technology is what it is. So this is going to be time measured in hours, right? It's not enough to say time, right? Because it could be minutes, could be years, could be months. And then that means the y-axis is going to be earnings. So I'm going to write earnings. And the earnings are in dollars. Okay, so Matt's here in blue. I'm going to plot blue and Matt in blue. So his first point is 1, 12. So I'm going to come down here. 1, 12. So put him a nice blue dot there. His next point is 220. So 220. And his last point here is 331. 331. Okay, so what I'm going to do next is I'm going to try and draw myself a line that connects all these dots. So if I do these two dots, and I'm going to draw the line, and I'm going to make sure I go all the way back through the y-axis. So let's see. It looks like I'm going to struggle connecting all the dots exactly. If I connect these two dots, notice that didn't, I got these two dots connected, but that's not on it. And if I connect these two dots, line these two up, I'm going to miss this one. So that's unfortunate. Anyways, it doesn't look like I can connect all the dots. But let's see, this is Matt. So Matt's in blue. And then let's do Jane in red. So, and we'll put little red squares for Jane. So Jane is 1 and 12. So they share this one point in common. And then 224. and 3, 3, 36, all the way up here. All right, it's the third line over. 1, 2, 3, 36. Now I'll do the same thing here, and I'll connect these. And I'm going to change the camera here for just a moment. So now we can see the whole paper. Come on, focus. But I'm going to try again. I'm going to try and connect all the points. James looks like it's going to cooperate a little bit more here. And yeah, sure enough, it goes through this point, and this point, and this point. And also, it goes through that point. And that's nice because visually, there's two things we're looking for. Does the line pass through the origin? That is, does it pass through 0, 0? And for Jane's, lo and behold, it passes through 0, 0. So that's one point. And that's one detail we're looking for. The other detail we're looking for is, do all the lines connect? Can I connect all the lines, all the dots, in a straight line? Can all dots, or points, right? Can all points be connected in a straight line? And for Jane, it looks like it, right? And it's all dots connected. Can be connected in one straight line. And for Jane, we can say that. So does the line pass through the origin? Yes. Do all the dots, can it be connected in one straight line? For Jane, that's yes. And that's what we need to test for proportionality. So Jane's relationship is proportional. Jane's relationship, I should say, between time and earnings is proportional. Time and earnings is proportional. And we could say it because the graph goes through a straight line, because the graph of the points is a straight line through the origin. And the origin again is the point 0, 0. So yeah, so we can see that Jane's not only proportional this way, that is by checking the ratios, but we also see that Jane's relationship is proportional because visually the line is straight through all the points and it goes through 0, 0. Hope this helps. Or whereas, Matt's, we can see it wasn't proportional here because the ratios weren't the same. And also, we can't get all the lines to connect, and it doesn't go through 0, 0. So we have these two ways now we can check for proportionality. One, by checking the ratios. Two, by graphing. Go out and be awesome at showing your work.